Okay, homework 1 has been graded, and I thought I would go over some things that I noticed, just because I thought you would probably have a lot of questions, and I could just direct you here instead of answering all of them all the time. I'm joking, I'm not that lazy. Okay, so the distribution, the mean was 1.5, about. It's a little bit less than that, but it's about 1.5. And most people got scores of. I was going to tell you the standard deviation, but the standard deviation is 0.4, or 0.5 rather, which makes sense because most people got a score between 1 and 2, so the standard deviation really doesn't tell you much. 1.75, which became 1.8 because the computer is unable to read, or it rounds to the 10th place, and 1.0, which became 1.0. What the actual points mean. So if you got 0 credit on a problem, that means there was no attempt. If you got, okay, and for this I'm going to use, where's my word? It's on the pen, of course. For this next one I'm going to use mind-searing red because I never get to use, I'm afraid of psychologically damaging people because of the harsh colors of red. So 1/4 equals a liar. You could not have gotten a 1/4 point. The minimum you could have gotten on a credit is 0, and the next one is 1/2. Okay, now that that's out of the way, if you got a score of 1/2, that means you attempted. And if you got a score of 3/4, it means you substantially attempted. You attempted all sections, but there were several errors. I shouldn't say several. There were 3 or more errors, and if you got 4 out of 4, you gotten 1 or 2 things wrong. Now note this. You might go like, oh, but I only made 1 mistake on the moment and shear diagram. Why is this wrong? The moment and shear diagram. This is mainly for problem 3. Number 2, unfortunately, because it was like fairly straightforward. Number 3 had a lot of different components. It was very intricate. Number 2 did not. Number 2 only had a couple of things, and it felt very hard for me to justify giving you 4 out of 4 when you like made 1 mistake, but the mistake was like a completely. The weight of that mistake is probably a lot more significant. So is that some basic things? I noticed that a lot of people did not get full credit on the moment and shear problem, and I was a little bit surprised because the moment and shear problem should be the free points in this homework section. One of the reasons why I graded it was I thought it would be free points, and the other reason was because it's actually extremely important that you're very familiar with moment and shear diagrams. So just a quick recap, like this. Exact numbers don't matter, but for a beam like this, you cannot have moments. You cannot have moments here or here. And that's because there's nothing to resist the moment. Like you just have a point. The reason why moments develop in, say, a cantilever is because it prevents rotation. But this does not prevent rotation. These things are free to deflect in any shape they want. Yeah, so be careful with that. Another thing is that axial forces, they're only resisted by this pin. But once they get to this pin, there's no axial forces. So there's no axial force here. So your axial force drawing looks like this. Tension positive. Those are the main things. Okay, so I'll probably mention this in lecture also, but please, please, please try to solve all your problems into a numerical solution. What do I mean by that is try to get rid of your square roots, your powers. Try to get rid of your sines and cosines. Because it's actually quite tedious to grade when everyone has like 5 different ways of expressing the same exact thing. So yeah, please try that. This became particularly prevalent here. Also, make sure you use whatever information is given to you. A lot of people messed up number 3. Because they used the forces they got from number 2, and I didn't really take off points for that too much. Like if you use the wrong numbers, I followed your reasoning, and I tried to justify giving you as many points as I could. But yeah, definitely look at the information that's given to you. You were given axial, you were given shear, and you were given moment. Yeah, that's all I had to say really about that. Like your axial, a lot of people were using 5, but in actuality given is 8.6. I don't know, I use certain things a lot. Like I say certain things a lot. I say actuality a lot. I shouldn't say in actuality. But yeah, people use 5, but it's given that the axial force is 8.66, which is equal to 5 times square root of 3. There's no need to calculate that. It was just given to you. Yeah, so I don't really know too much about that. A lot of people did not draw the stress block diagrams, and I'll just draw. This is your normal system. Your normal system before you rotate it has something like this, and you rotate it to get your principal stresses. And you rotate this by theta p. Or you can rotate it another way. And this becomes theta s. And theta p plus or minus 45 degrees equals theta s. And those are really your, like this is, I forgot to draw. Note that tau here is equal to 0. Like that's all you really had to draw. So yeah, again, let us know if you have any questions about homework 1. Homework 2 has been posted already, and videos for that are actually up already. Videos for the first 3 problems. Videos for the video for the 4th problem isn't up yet because I've been too lazy to make one. But hey, I wanted to have some fun on the weekend too, you know. Yes, just let us know if you have any questions with this.